So my name is Susan Spenser. I am a PhD in microsystems engineering, which is a PhD program here at RIT that I highly recommend for any students in the audience. And what I did during my PhD was design, optimize, fabricate, and attempt to understand something called organic solar cells. So the work that I've done here at RIT has been really focused on third-generation solar technologies that are going to help revolutionize solar by reducing the cost dramatically. What I'm going to talk to you about today is kind of the driving force behind a lot of the switches to renewables, and that is the climate crisis. So I'll be going through and explaining global warming, how we're causing it, and the effects that it's having here and now on our planet. I'll then be talking about the renewable energy solutions that we can use and the things that you guys can do here in your community, in your lives, and at a global scale. So, and as Enid said, I'm an ambassador from the Climate Reality Project. So this is Mr. Gore's personal foundation, and the goal of the foundation is to train regular people like myself. It's not all a bunch of doctors. There's teachers, there's musicians, there's artists, there's students, there's moms, there's preachers, every type of kind of quadrant of humanity that you can imagine. And what we do is we go back home after our training into our communities and we talk to as many people as we possibly can about climate change. So I've talked to 4 people in a living room, and I'll be talking to 2,000 people next month at Rochester TEDx. So there's no group too small or too big that can be educated about climate change. So thank you, everyone, for coming today. I want to start by reminding everybody that we have one planet to live on. This is all that we get. This is one of the most famous pictures of Earth. This was taken from one of our very first modules that was sent into orbit. So what you're seeing here is every single person who's ever lived or died. This is where we live. This is our home. And if we don't take care of it, we won't be able to live on it. The reason why our planet is so great is because of this super thin layer that surrounds it. And this is, of course, our atmosphere. What does the atmosphere do? Well, it does something called the greenhouse effect. So what is the greenhouse effect? This is the sun. This is our planet. This is our atmosphere here. You can see how thin it really is relative to the size of the Earth. So solar radiation is emitted by the sun, and it passes through the atmosphere, and the Earth absorbs this radiation, and that warms our planet. Some of it, however, is radiated back into space, and that's typically in the form of infrared waves. But some of this outgoing radiation is trapped. So this is what's warming the surface of our planet, is this trapped radiation here. This is good. This is what allows us to have a planet that is actually inhabitable. So if we compare the planets that we're closest to, you've got Earth with a Earth-sized atmosphere. Venus has a much thicker atmosphere. So this is shown with the thickness of the blue circle. Earth, global temperature average 59 degrees Fahrenheit. Venus is 855 degrees Fahrenheit. And you might say to yourself, as smart people, well, Venus is closer to the sun, Susan, so of course it's going to be warmer. True. But Mercury is even closer to the sun than Venus. But because of the thinness of its atmosphere, it's only 333 degrees Fahrenheit. So I'm hoping that what this hits home to you is how important the atmosphere is in maintaining the temperature of the planet that we live on. So my PowerPoint just kind of froze for a minute. Sorry about that. So when the atmosphere gets thicker and when we put more greenhouse gases into it, what happens is that more radiation can actually be trapped. So what are greenhouse gases? Well, they are CO2, carbon dioxide, and they are methane, CH4. And these gases, while they exist in nature, are pumped into the atmosphere at a very alarming rate by human activity. So this is showing an enormous amount of human activity. I'm going to be focusing on fossil fuels, so coal plants, coal mining, oil production, All of these things here, though, do contribute at different levels to the amount of greenhouse gases that are going into the atmosphere, changing the concentration and density of the atmosphere and warming up our planet. So before I go forward, sometimes I have climate deniers in the audience, so I like to remind everyone that this is not up for debate. This is settled science that we can all agree on if we trust and understand the scientific method. So this is from November 2012 to December 2013. 9,136 authors agreed that climate change was real and that it is primarily caused by human activity, and 1 disagreed. And this guy's disagreement, we're allowed to disagree in science, that's okay. This guy's disagreement is the causation of it. He believes in global warming and he believes that it's impacting climate change, but he doesn't think that it's primarily caused by human activity. 9,136 authors to 1. So 99.99% of peer-reviewed climate papers agree. What else? Every National Academy of Science of every major country in the world confirms anthropogenic, man-made global warming. No national academies reject this science. The national academies believe that urgent action to address climate change is indisputable. In fields that are related to the study of global warming, every major scientific society in the world within those fields confirms the consensus of evidence. So, it's not up for debate. We are emitting greenhouse gases. Those greenhouse gases are changing the atmosphere. They are trapping more heat. They're warming the planet. So let's focus on what that actually looks like. So this is million metric tons of carbon that we're emitting from fossil fuels. This here is the industrial era, the Industrial Revolution. And then as we move into the 1950s, we have this massive spike. And we are now emitting never-before-seen levels of carbon that are getting put into the atmosphere. So as the carbon dioxide concentration increases, so does the temperature. And you can see that here on the left-hand side is CO2 concentration in parts per million. Here on the right-hand side is temperature change in degrees Celsius over the planet. And we're going from 0 AD up until 2000. Both of these graphs have the same trend line. It's called the hockey stick trend. So what we see is as we have this incredibly sharp increase in CO2 concentration, we also have a sharp increase in our global temperature. So to put this in different perspective for you, it's the same thing as 400,000 Hiroshima-grade atomic bombs exploding every single day, every day of the year. This is an enormous amount of energy that is being trapped by the atmosphere that we have changed. So let's look at some data. PhD in engineering, right? I'm a data nerd. This is what I like to talk about most. What you're seeing here is a bell curve, a Gaussian distribution. So these are deviations from the mean. This is the average. These are warmer than average days over here. These are cooler than average days over here. This is the frequency of occurrence. How often is it really hot? Yeah, it's not very often, right? How often is it really cold? Not very often. It's pretty much regular. So what we're looking at here is the baseline. This is from 1951 to 1980. So remember, this is our baseline. When we look at 1981 and 1991, we need a new color. And that's down here. This is extremely hot. So we're now having extremely hot weather events occurring. These are where temperatures are going above 110 degrees Fahrenheit and staying there. You're not cooling off at night. So now 1991 to 2001, you can see that the bell curve is shifting further to the right. This is the standard, or the initial baseline still. And finally up to present day. And what this means is that these events here, which used to cover 0.1% of the planet, now cover 10% of the planet. It's 100 times more. It's an enormous change. And these weather events have absolutely catastrophic effects. 37th consecutive year with a global temperature above the 20th century average. May 2014 was our 351st consecutive month with a global temperature above the 20th century average. These are consistent trends, and we see them no matter how we look at the data. So we're going to look at it now decadally. So these are each representing decades, and this is the average temperature, and you can see that as we go from the industrial era up into present day, we have an increase in global temperature. 4 independent records. So these are taken in the UK, US again, and Japan, and we get the exact same trend as a function of year. So as we increase in time with the burning of fossil fuels and the increase in CO2 concentration, we see the simultaneous increase of our global temperature. Okay, so it's getting warmer. What does that mean? Well, we have a giant heat sink, right? And 90% of all of this extra heat is getting trapped in our ocean. So now let's look at the global, or the ocean heat content. This is in the top 2,000 meters of the ocean. And this is heat content measured in 10 to the 22 joules. So this is energy that we're thinking about. And this is by year. So as we go on in time, increasing CO2 concentration, remember, we're increasing the heat in our oceans. Okay, oceans are huge. They're covering, 70% of the planet. We can probably put a lot of heat into them, right? And not have too many dramatic effects. Well, no. What you're seeing here, this is the ocean. These are the Philippines. And these, the colors overlaid on the oceans are showing sea surface temperature anomalies. So the red here, this is 9 degrees warmer than usual, 9 degrees Fahrenheit warmer than usual. So what happens is a storm comes along and it picks up energy from these increased sea surface temperatures, and you end up with Super Typhoon Haiyan. So this is the Philippines. This storm is the size of the Philippines. This happened in 2013, and it absolutely devastated the region. They still have not recovered from this. 4 million people were displaced by this typhoon, twice as many as the Christmas Day tsunami. So we think about this horrible catastrophe, and it's one event, right? But this is one of the largest reinsurance companies in the world, Munich Re. They believe that the only plausible explanation for the rise in weather-related catastrophes is climate change. So this is not a bunch of hippies. This is not a bunch of environmental activists. This is reinsurance companies who control movements of vast amounts of money throughout the world. This is the other one. The long-term effect of climate change is what keeps us up at night, and it really frightens us. Why, you ask? Because the ocean also touches the United States. So what I want to show you here, we're looking at the same type of graph. So we're at +9 Fahrenheit for the red portions. October 29th, 2012. I don't know who here would remember what day that is, but I want to focus your attention right here off the coast of New Jersey and New York City. We had sea surface temperature anomalies, which allowed for the formation of Hurricane or Superstorm Sandy. And Superstorm Sandy completely devastated Manhattan. And Manhattan is where the world's largest reinsurance companies keep their money and they keep their property. And this was a huge wake-up call for a lot of individuals that this isn't just happening in the Philippines, this isn't just happening in the Indian Ocean, this is going to be happening globally, and it's going to affect us all. So this is the National Center for Atmospheric Research. The amount of global warming that we now have, the damage that we have done, all storms are forming in an environment that has changed because of human activities. We have had enough of an impact that the storms that form, whether it's the Philippines or the coast of New York City, are forming stronger, with more power, more energy that they're gathering from the ocean, and this is because of the fossil fuels that we've emitted that have warmed up the planet and sunk all of that heat into the ocean. So there's more that happens when we warm up the ocean and warm up the planet. We get more and more extreme weather of all kinds. Why is that? It's because of the hydrological cycle. So as temperatures increase, the oceans are able to evaporate more moisture into the sky. I'm assuming most people in here are fairly familiar with this. So the more evaporation you get, the more precipitation you get. Water comes back to the sea, more evaporation, cyclic. The interesting thing is the warmer air actually has a greater capacity to hold more water vapor. What does this mean? Well, with every degree Celsius of temperature increase, 7% more capacity to hold water vapor. So not only is it evaporating more, are the oceans evaporating more, the air above them is able to hold more of that water vapor. So there's already 4% more water vapor over the oceans than there was 30 years ago. And you can see the impact that that has. If there's more water vapor in the air, we're going to be getting heavier precipitation all over the place. So these are the change in annual global temperature. We've got it going up here at the end. And here's the increase in heavy precipitation days. So we see the same upward trend. So the downpours are getting larger. This is taken in Canada, and I'm worried I'm going to fall, so I'm just going to bring this with me because I have to point this out to you. Right down here, this is a house. So for scale, that shows you the size of this downpour. So it's almost like instead of just having me pouring out a pitcher of water, this is now a giant bathtub that I've pulled the drain from, and everything in the bathtub is rushing out of where that drain empties. And this causes catastrophic flooding that people are completely unprepared for because we haven't seen rainfalls like this. These are 10,000-year storms that are now happening yearly, and they're happening everywhere. So this is in Canada. This was a year later in Washington. This was a massive mudslide. This is in Pensacola, Florida, 2 feet of rain in 26 hours. This is a video. The people videotaping are getting very upset because there's people in this car. So this was a completely unexpected downpour that wiped out an enormous part of Pensacola. But this isn't just happening in North America. This is happening all over the world. And these increasing downpours are increasing the severity and the resulting human tragedy of these floods. So this is Pakistan, Afghanistan, Croatia, Serbia, Bosnia. I like it when dogs get rescued. I think that's great. Solomon Islands. Thousands left homeless from this flood. This is in Bolivia. China. These are all taken in the last 3 years. 3 of 4 in 2014 now. Again, this is Sichuan province in China. This is Brazil. India. Millions of people left homeless in about 3 days of flooding. Great Britain had the wettest winter on record in 2013 to 2014, resulting in never-before-seen floods in places of England that just don't flood like this. So this is Somerset. This is Wales, Scotland, Sweden, Germany. That's a hotel there, and you can see that the water is completely covering the entire first floor of the entire city of Passau. This is Austria, the Czech Republic, Slovak Republic, Hungary, North Korea. I hope the point that I'm getting across to you is that this is happening in almost every single country, in every single continent, all over the world. These catastrophic floods. Mozambique, the Sudan flooded. It's not an area that is prone to flooding. This is Mexico. The people in this picture were rescued. Argentina, Greece, Australia. This is a road here that you're seeing is completely wiped out. So we are seeing this incredible increase in catastrophic flooding, which is going to continue to intensify the Earth's water cycle. So as we continue warming up the Earth, we're going to get more and more and more evaporation. Evaporation is not just going to give us more downpours, it's also going to give us bigger droughts and more sustained droughts, because we're going to be getting more evaporation off of land as well as the ocean. So evaporation increases even more. The air gets warmer, it can hold more water vapor. The heavy downpours get worse, so the flooding intensifies. Intensified flooding plus warming temperatures mean the snowpacks are melting earlier. That gives more spring flooding and less water in the summertime. So we have longer intervals in drought-stricken areas, making the droughts even worse, and more water is evaporating quickly from the soil. So the droughts are deeper and they last longer. So all of these are also from the last 3 years. So simultaneously with the flooding, we're seeing intensified droughts. This is a reservoir where water is typically kept in Indiana. This is Macedonia. The water is typically up to here. This is the top of the dam. This is in Spain. The driest winter in 70 years happened in this decade. This is in Brazil. This is New South Wales. So this little girl is leaping across the Murray River, which typically goes from this bank all the way over to this bank. This is New Zealand, South Korea. The worst drought in 2012, they had the worst drought since record keeping began. This is in China. They had to come up with a new color. So brown for extremely dry. So this is here, and a lot of the country is also red, severely dry. The effect of these droughts, lakes are drying up. And people are having to walk miles and miles to get water for their families, for their livestock, for their crops. The Amazon, this is called the greenness index. So more green is green, which is helpful. Less green is reddish. So what you're seeing up here, this is the only kind of green portion of the Amazon. This drought is being called a mega drought. And we lost 250 million hectares of greenness in the Amazon. This was NASA's approximation based on their work. And it's an area twice the size of California that is continuing to suffer these effects. So this is in Manaus. This is typically a giant river. You can see a bridge over here that goes over it. It's gone. So, okay, we have droughts, we have flooding. Both of these things can increase the potential for human conflict, not just human loss and devastation. So, in Syria, 60% of their land was turned into desert in this drought. 80% of their cattle were killed. 80%. So this man was a farmer, and he is now a refugee. This was formerly arable land in Syria. Over 1 million people fled their homes because of this drought, and they ran smack into the millions that were fleeing Iraq because of the war and conflict. And it's now being recognized, thanks to WikiLeaks, among other sources, that this was one of the primary instigators for the civil war that we are now still trying to deal with in Syria. The drought was beyond our capacity as a country to deal with. These weather events can cause systemic breakdowns of entire countries' infrastructures. And this leads to the DOD, this is May 2014, but the Pentagon just released a major statement saying that climate change is a mandate. So again, it's not a bunch of hippies over at the Pentagon or environmental activists. These are people that recognize, as they say here, this is a mission reality, not a political debate. More Arctic ice melt, more sea level rise, intense storms, more flooding, and more drought. And they recognize that when this happens, humans are enormously impacted, and oftentimes the poorest and the most at risk are impacted the hardest. So what happens after drought? Unfortunately, desertification happens after drought. So this is in Turkey. These are farmlands here, and these are sand dunes that are encroaching onto this land. I think this next picture gives a much better idea of how severe this is. These are the sand dunes, and they are marching their way in. So once these sand dunes have come in, the land is no longer fertile. You can't use this land. It needs to be refurbished almost once this has happened. So it destroys cropland, and it allows for the formation of giant dust storms. So this is in New South Wales, the Opera House you can kind of see in the background here. This is in Sydney, of course. This is in India. This is a giant dust storm. And this is in Phoenix. So currently, we are, people much smarter than me, geologists, farmers, believe that we're creating another dust bowl. So the dust bowl and the effect that that had on the Great Depression was enormous because it essentially wiped out huge amounts of America's farmland, wiping out jobs and wiping out our ability to feed ourselves. And we're doing it all over again. This picture was taken by a farmer, Jane Stolp. No question in our mind that there are significant changes going on in our climate. You ask somebody who's living in climate change, who's dealing with it on a day-to-day basis, they don't think it's a political question. They recognize that it is a reality. So when we think about food and when we think about America's ability to grow crops, California is it's our largest producer of produce. 100% of the state is in at least a severe drought. Again, we have a new color. So I think the name is unfortunate. Exceptional drought makes it sound like it's a good thing. It's not. This is an incredibly bad drought. One of the reasons for this, the average snowpack is 40 inches. And in 2014, it was 0. So again, this is one of the things in the bullets around the thermometer that I showed you. The snowpack is going to decrease because there's going to be flooding, taking away the snow, and there's also warmer temperatures that aren't allowing it to form and stay. When that happens, we get droughts. So this is Folsom Lake. This is one of the biggest reservoirs in California. This is 2011, and this is 2014. This is another lake in 2014. This is a reservoir. And remember, this is in California that is making an enormous amount of the produce that we eat, even here in Rochester. And as California dries up, the amount of fires that are there are going to increase. And that's actually for a couple reasons. Hotter years typically have more fires. So as the warm weather increases, we're going to have more fires. But as we dry everything out, we're also going to have more fires. So here you can see the average temperature, and we've got a lot of spikes because we're really zoomed in here. But the interesting thing is the fire trends actually mirror the same spikes. So as we increase the temperature, we're going to get more fires. And as we get more fires, we're going to again cause more human catastrophe. Loss of life, loss of property, loss of livestock, loss of land, loss of forests. So this is in Colorado. I don't know why it's not playing for everybody.
1,000 firefighters overwhelmed what they call a firestorm of epic proportions. It's as bad as it gets out there right now.
And this is not my laptop, so I apologize for the confusion. Okay, there we go. So what they're showing here is one of the worst fires that Colorado had ever seen. It devastated an entire canyon. There was some loss of life and an enormous amount of loss of property. This is the governor, and he is very upset, describing the scene as something that you would see on a movie set. So what I'm about to show you, this is actually the first forecast that I'm showing you. I've been showing you all real data up until this point. But this is modeling that's been done by NOAA, and what this model is going to show you is how the drought conditions are going to change globally. These here are the bad colors, so all of the kind of light lavender colors. And this is forecast for a temperature increase of 3 degrees Celsius above what it is right now. So this is 2000 to 2009. This is real numbers. This is real data. I want to draw your attention to the American Midwest, our breadbasket. This is 2030 to 2039. Remember, this is with just 3 degrees Celsius of temperature increase. We are already at one of the purples. And we're now moving to this very bad light color. This is 2060 to 2069. Finally, this is 2090 to 2099. So we've lost the American Midwest as a grower and producer of grain, and the Mediterranean is devastated. The top of South America, parts of Mexico. If we allow the temperature to rise by 3 degrees Celsius, this is what the forecast is showing us. We're going to need a lot more water then, right? Because 70% of our water usage is agriculture. It's in growing food. And if we are experiencing these drought conditions, we are not going to be able to get enough water for our crops. And this is going to have an enormous impact. So we will be experiencing water shortages, which is going to impact people, crops, the energy industry, livestock, and all industries that use water. So another global system is health. And this is an unfortunate fact, but climate change is really good for infectious disease. Mosquitoes and bacteria and viruses like it when it gets warmer. So mosquitoes are able to move to higher elevations and higher latitudes. And we start to get new or re-emerging diseases. This one is, of course, in the news. Ebola appears to have emerged again spontaneously because the complete deforestation of an area around a village allowed fruit bats to migrate into the village where they wouldn't typically go. And they brought Ebola with them. Some of the other ones, hantavirus is a really nasty one that you find in mouse dung. And that's now spreading out from the American Southwest into the American Midwest. None of these are good. And then we have some more familiar ones. One that's very prominent here is, of course, West Nile virus. That's one that I think a lot of us are aware of who've lived in the Rochester area for a long time. As it gets warmer, these diseases are able to move to more regions and newer regions. Now, of course, other things are bringing them, right? We have increased transportation, we have deforestation, there's other reasons why these are emerging, but climate change is going to just make it easier for them to spread farther. And finally, infrastructure. So this was in a 3-day heat wave in DC where temperatures stayed above 105 degrees for 3 days, and the tarmac melted around the planes. So planes were unable to leave the Reagan National Airport because they had actually melted into this tarmac. The tarmac that we have, the concrete that we use, the sidewalks that we make, the railroads that we build, they're not ready for the amount of water, the amount of changing temperatures that's going to be hitting us. So that was Vermont, this is Mexico, this is Alberta, England, Bosnia. My personal favorite, this is Avon, New York. So this was all over the news when we had one roadway collapse here locally. Now, I can't point to this roadway and say to you that this was caused by climate change. That's not a causation that I can make. What I can say is that this was caused by a flooding event. We are going to be having an increased number of flooding events here in Western New York. And these increased flooding events are going to cause more and more and more roads to wash out. Our transportation system is not ready. So finally, we move to one of the more highly talked about, speculated on, aggressively modeled arenas, and that's melting ice, whether it be glaciers or the ice caps. So first, if we look at permafrost, as the permafrost thaws, we're going to be seeing, there's an estimate of 250,000 metric tons of methane into the atmosphere each year. Methane is 25% more, 25% better at trapping the heat when it gets into the atmosphere. So it's even more of a dangerous gas to be released than the carbon dioxide. We're going to be experiencing more and more glacier retreats. So this is 1984, and this is 2012. This is in Alaska. This is a famous one, the Muir Glacier, named for John Muir, famous conservationist. It's gone completely. This is in Peru from 1978 to 2004. 67 minutes compressed to 28 seconds. And what you're seeing, this is about 4 miles wide here. So this is not like an up-close shot. This is taken from very, very, very far away, and you're seeing an enormous amount of the glacier just calve right off into the sea. So now let's talk about the ice caps. In the Arctic, we have been losing sea ice, and we have reached a new record low in 2012 that we've now surpassed in 2013. You can see it very visually here. This is 1984. This is 2012. And when we go to the other side of the Earth, it's an even more stark picture. So the West Antarctic ice sheet is a land-based ice sheet, and it appears to be moving much faster than it was. The reason for this is this is a marine ice sheet, and over here is the land ice sheet. So the ocean is warming up, and as the ocean warms up, we're melting the marine ice sheet, and that's going to start calving more and more icebergs off. And what it's essentially doing is pulling the land ice off of Antarctica. What does this mean? It means that ice that was not in the ocean is being dragged into the ocean and melted. And in May 17th, 2014, it was announced that we have lost the West Antarctic ice sheet. There's nothing that we can do to stop it from melting into the ocean. Nothing. It's gone. The only thing that we can control is how fast it melts and if we can manage to keep the rest of the Antarctic frozen. This is very stark reality, to lose something as large as an entire ice sheet. These problems indicate that we need to change. We cannot keep going in the same fashion that we have. The way that we currently consume fossil fuels is incredibly dangerous to our species as well as every other species on the planet. This is the BP oil disaster. So this is right here in Arkansas. What you're seeing here is the effects of one of the tar sands pipelines rupturing. So oil companies don't really want to hear any of the things that I've just said. They would like to keep making money. So they're building pipelines stretching down from the Canada tar sands to the Gulf of Mexico. But sometimes accidents happen. These pipelines rupture, and you end up with this incredibly toxic mix of oil and bitumen spilling through your entire neighborhood, destroying wildlife, destroying homes, creating a toxic environment for families. And the change is not going to come from the oil companies and from the fossil fuel companies. This quote, so this is Rex Tillerson, CEO of ExxonMobil. What good is it to save the planet if humanity suffers? The level of cognitive dissonance there is mind-blowing to me. He doesn't seem to understand that we live here, and if we don't save a habitable planet for ourselves, the suffering is going to be untold. In his mind, we shouldn't worry about it. We shouldn't have to care. So what that leads me to is the true cost of carbon. So He wants us to keep buying gas and putting it in our cars and keep heating our homes and keep charging all of our stuff and keep using fossil fuels because it's cheap. It's cheap. It doesn't cost a lot of money because the true cost of carbon is not actually factored into the price we pay at the pump or the price we pay on our electricity bills. So all of these things that you're seeing here are the result of fossil fuel use because that fossil fuel use is putting emissions into the atmosphere and that's warming the planet. All of these things are going to completely destroy the world as we know it. So, if I ended my presentation there, I think we'd all walk out like really upset and not feeling very good because that's a lot of depressing information to throw at you in a pretty short time. But there's really good news. We can fix this. There's two things that have to be done immediately. We have to put a price on carbon in the markets, so people at the high levels of the fossil fuel industry need to start recognizing what the actual cost of their policies are, and we need to put a price on denial in politics. There's over 100 climate change deniers in the United States Congress right now as we speak. Some of them sit on our Science and Technology Committee. That's problematic. How do we give solutions that allow for these things to happen? Because you can't go to Congress and say, this stuff's really bad. You have to go with solutions. Well, we have green energy and we have renewables. So let's start by talking about wind. So in 2000, it was projected that we'd get 30 gigawatts of energy from wind, worldwide wind capacity, by 2010. And in reality, it was exceeded by a factor of 10 times. Fantastic. So we're growing faster than we thought we would. Again, 2000, China, 2 gigawatts by 2010. The reality is amazing, 22 times. And by 2020, they're going to exceed it by 75 times. So this single turbine in Denmark can power 6,000 homes. This is the London Array in England, the world's largest offshore wind farm. 470,000 homes can be powered with this. This is in Kenya, Morocco, Turkey. So these are not wealthy countries. These are not first world superpowers who can just, oh, we can put up whatever we want. No, these are regular countries. This is India. They want to quadruple renewable energy generation by 2022. China, Mexico, they've got one of the world's largest wind farms, Oregon, and Australia. So in Australia, wind energy is now cheaper than electricity from new coal or natural gas plants. What is the significance of that? Australia is essentially made of coal. It's very, very easy to get coal out of the ground in Australia. And the fact that it is now cheaper than coal and gas in this country that is essentially made of coal and gas, he calls it a game changer. This guy's another hippie, the chief executive of Bloomberg New Energy Finance. People are recognizing that these renewable energy technologies are the way to go and that they are not as expensive as they are made out to be. So I told you guys I make organic solar cells. Solar's kind of my baby. So in 2002, solar energy market is going to grow 1 gigawatt per year by 2010. It was exceeded by 17 times. And then in 2013, 39 times. 2014, 55 times. It's an exponential growth of solar. Let's look at that exponential growth. There it is. So this is the world solar photovoltaics production in terms of megawatts per year, and this is yearly, so we're just kind of slumping along here, and then we have this enormous exponential growth. So this is by country. Here's the US, Germany, Japan, Taiwan, China. China's literally off the charts. And they're not just producing this and selling it here in Mexico and wherever. They're producing it and installing it in China. They're absolutely revolutionizing the way that the world has to look at renewable energies. Has this ever happened before? And this is quite unique for a new technology to be adopted so rapidly, so efficiently, and so well? Well, cell phones. AT&T said 900,000 users by the year 2000, back in 1980. They looked really dumb in 1980, so I can kind of understand why they only projected 900,000. But it was actually 109 million by the year 2000, so 120 times higher than the prediction. And we now have 6.3 billion cell phone connections. So they were incredibly, incredibly wrong with their projection. And the question that we need to ask is, why is that? Here's Mr. Gore using a cell phone in 1980. There's 4 reasons, and these 4 reasons are the exact same reasons that are driving the increase in solar production. First, the cost drops because the quality improves. The ability to buy solar can be done by an individual, just like the ability to buy a cell phone. And countries that don't have established grid technologies don't need them. They can use a cell phone without a landline grid, and they can put solar on their house without an electric grid. There may be a tipping point that causes customers to seek an off-grid approach to solar. That's like saying there may be a tipping point that causes customers to seek a cell phone approach as opposed to a landline. So here we go. Examples of solar technology. This is in South Sudan. Pay-as-you-go solar, solar-powered laptops in Sierra Leone. In Bangladesh, 2 per minute solar PV systems are being installed. You can see that there, another exponential growth curve. Fantastic. 1 in 10 homes in Australia now have solar systems installed. And this is because the cost is dropping sharply. So not only is the cost of solar dropping sharply, so is the cost of storing this energy. So you can see the cost of a battery decreasing. This is 2012. By 2020, it's projected to be around $200. What is going to happen is that we're going to reach solar grid parity. Solar grid parity is where the cost for getting solar onto your house and getting your electricity from it is equal or less than staying on the grid. So solar and the cost of getting it and installing it and using it is equal or less than just staying on the grid. So 2014, these are the countries, balmy tropical Greenland up here, that have achieved solar grid parity. The amazing thing is, by 2020, 82% of the world's population is going to live where solar grid parity has been achieved. This is what is going to allow us to mitigate the damage we've already done with the CO2 emissions and stop any future increases in temperature. And then by 2024, the vast majority of the world will have achieved it. So until then, until we're off the grid with solar in everybody's houses, there's a lot of gigantic solar farms that are being set up here. So this is in Morocco. The Vatican has solar, which I think is fairly impressive. The Philippines, this is a research facility there. California, this is the UK's largest solar farm. Again, UK is not really known for being an incredibly sunny place, but the technology has improved dramatically. You don't need to be in an equatorial region to use this. You can put it on your house here in Rochester. This is Ivampa. This is a solar concentrator. It can power 140,000 homes. Arizona, this is the world's largest one. And then we get to China. So in 2010, China's president said, "Green and sustainable development represents the trend of our times." And he didn't just say it, he acted on it. So in 2013, 12 gigawatts were installed, a record for any country, and almost equal to our entire capacity. So in 1 year, China installed almost the entire capacity of the US solar. They're doing fantastic. And you know what? China can drive global markets. So for the first time in 2010, we saw a greater amount of investment in renewables than in fossil fuel. That's fantastic. Again, this is good news. This is the happy portion of my talk. So here are US solar PV installations. So here in 2012, it was up 75% over 2011. And then in 2013, it was up another 41%. The good news is in 2014, it's projected to be up another 60% on top of that. Asia Pacific region, we have an increase in clean energy investments. And again, Citibank, another very large institution, is saying the age of renewables is beginning. We have countries with carbon policies. We have some countries without carbon policies. Kind of a very specific one that I'm trying to highlight there for everybody. And again, who can we look to? We can look to China. So China has some amazing pilot carbon programs. They've got cap and trade in 5 cities and 2 provinces with a nationwide rollout in 2015, a nationwide rollout of cap and trade. They have a coal-fired plants ban taking place in these 3 cities. Europe is going to cut its emissions by 40% by 2030 and produce 27% of its energy from renewable sources. This is a binding agreement that's been signed in the European Union. How are we doing in the US? Well, we proposed a bunch of coal plants. So these are all the new coal plants that were proposed, but because of the actions of groups like the Sierra Club and the National Resource Defense Council and some political parties and a lot of grassroots activism, these were all canceled. So this is good news. We're starting to shift the culture, right? And why are we doing this? What are we fighting for? Why am I talking to you now with such urgency? Because we have to limit global warming to 2 degrees Celsius to avoid a complete systemic breakdown. In order to do that, we have to sign the Paris Accords. So this is a global treaty that's going to be signed in Paris. This is similar to the Kyoto Protocol, except the goal is, for the very first time ever, to get everyone to actually sign it. So it's going to be a binding and universal agreement signed by all nations of the world. How on earth could you guys possibly assist in getting this treaty signed? Well, we have to speak up, we have to be active, and we have to start talking at the dinner table, at church, at school, at work. I have a reputation of being mildly obnoxious because I don't shut up about climate change. That's fine, I don't mind, as long as the message is getting out there. The United States has to sign the treaty. So the current climate of denialism and this kind of equal viewpoints, it has to be challenged. So you have to step up and say, you can't deny climate change, it's scientifically factual. The reason why, you're not going to be changing the hardcore denialists. You're going to be influencing everybody else's perception of this debate, right? Because it's not a debate. We have a consensus. So if we can all emphasize the consensus over and over and over and over again, it's going to shift public perception, which is going to shift the political will and the political mandate. So what I'm showing you here, this is actually a really interesting graph. I highly recommend this website, skepticalscience.com. A friend of mine, John Cook, made it, and it's brilliant. It goes through pretty much every single thing that you might ever get asked about climate change and global warming. So percentage of climate papers endorsing anthropogenic global warming. It's always been in between 80 and 100% ever since the early 1990s. You can see that here. These trend lines stay about the same. These are 2 different ways of calculating that endorsement. What each of these are showing are major attacks on this consensus. Why would they do that? Because then they can shift the public perception. This is the reality. There's a 97% consensus of evidence among scientists that anthropogenic global warming is real. Percent of climate scientists agreeing on human-caused global warming. The public thinks that it's 50-50. That public perception is incredibly damaging to establishing political will and political mandate. I'm not going to make you read all this, but people who believe scientists disagree are less likely to support climate policy. In order to effectively counter the denial machines campaign, we have to increase the public's awareness of the consensus, because this is what's going to increase the support for emission reduction policies. By increasing public support, you create the political will. By creating the political will, you helped to get the treaty signed and ratified by the US Congress in 2015. It's not that far away. It's next year. So, I said you have to address denial, right? That's really brutal to do sometimes, because a lot of times the people that believe that the global warming isn't real, they can be not the most pleasant people to speak with. But there's a really standard way that you can pull apart their arguments. It's called FLIC. So you want to recognize, illuminate, and emphasize FLIC. People who deny science, whether it's global warming, vaccines, people who deny scientific method and scientific evidence rely on this. They'll cite fake experts. They'll use logical fallacies. They'll bring up impossible expectations. We want 100% consensus of evidence from all scientists everywhere in the world from 1850 to 2090. That's not an actual thing that we can ask for. They'll cherry pick. So they'll say, well, in Rochester, it was colder last year and we got more snow. So global warming's not real. And they'll use conspiracy theories. I've been accused of being a shill for Al Gore because he's going to magically reappear into the political arena and run in 2016. So these are the things that will be relied upon. If you enjoy watching people argue about this kind of stuff, you can follow me on Twitter, where I regularly debate with these people. And again, the whole reason is so that all of my followers, all of the silent majority that's watching, sees that the denial does not go unchallenged, and they hear what the actual consensus of evidence is. Other stuff you can do. This is kind of, the standard be a good planet citizen talk here, right? So make consumer choices that reduce energy use, consider the environmental impact of the items you buy, switch to renewable energy sources. You can do that with RG&E. You can switch to wind power. You can put solar on your house. Now, I don't own a house, so I have nothing to put solar on. But for those of us that do own homes, it's a great choice, and it's a wonderful thing to switch to. And I'm happy to help you understand the grants and the entire process of getting solar. You can email me for a free consultation there. I don't work for anyone that does it, so it's, I'm just doing it to help out. But finally, we have to do more than just change our light bulbs, right? We've been changing light bulbs for the last 30 years, and it hasn't done enough. We have to change laws. So one of the ways that you can do this is by actually talking with and engaging your political leaders. Write letters, write editorials, call your politicians, vote, please. And make sure that when you talk to these people, they know that you're going to support or oppose them based on what they say and do about solving the climate crisis. Get a statement from them about what they believe is true with anthropogenic global warming. So, I just want to remind everybody again, this is all that we have, is this tiny planet, and if we don't take action now to keep the temperature increase at 2 degrees Celsius, we're not going to be living on the planet that we're used to. Our children and our grandchildren won't be living on the planet that we're used to. And I think that the imperative need for action starts here and starts with you guys. So I hope that you got a lot of information out of this. Write down my email, contact me with questions. I'm always happy to talk to people about this, and if you have more questions than what I can answer here, please give me an email. Thank you so much for listening, and I'll take any questions that anybody has now.